Hello, these are the notes for section 8.4 on polar bonds and molecules. So we have three learning goals for this section. Using the values for electronegativity, determine whether a bond is nonpolar or a polar bond between the two elements. And then evaluate the impact that intermolecular attractions have upon physical properties of a compound. And distinguish between types of intermolecular attractions, especially ionic bond versus covalent bonds, and then we have dipole, dispersion, and hydrogen bonding. All right. So we start by talking about bond polarity. So we use electronegativity differences to figure out bond polarity. Before, in an earlier chapter, we talked about the trends for electronegativity. In that, in the top right part of your periodic table, we have the higher electronegativities. The noble gases don't count for the trends on electronegativity, so fluorine is going to be your most electronegative element. And then as we move down and to the left on the periodic table, those values decrease. Now, this chapter, to figure out the types of bonds, we're going to use the numbers that are associated with electronegativities. And those numbers will be given to you as we need them, okay? All right, so starting off with the nonpolar covalent bonds. This is when the atoms attract the electrons equally. So the electrons are equally shared between the two atoms in a covalent bond. So this happens when you have two atoms that have the same electronegativity or at least very close electronegativity values. The next one is polar covalent bond. So this is when you have an unequal electronegativities. So the more electronegative atom is going to attract the electrons more strongly. So it's like a tug of war situation where one team is stronger, so they're going to pull those electrons closer to themselves. So the more electronegative atom is going to have a greater share of the electrons. So what this does is it creates a polar bond. And then what that means is that the more electronegative end is going to gain a slight negative charge. That means the more electronegative end, it's going to have a stronger pull on the shared pair of electrons. And then electrons are negative, so that the negative charge is going to be more towards the more electronegative atom that's in that shared in that bond. The less electronegative end is going to gain a slight positive charge because they have less of a share of the electrons. And we show this, there's a couple different ways that we show this. We can use this lowercase Greek letter delta, which looks like this right here, or an arrow pointing to the more electronegative atom. So here's a couple of examples right down here. So in HCl, this is a polar bond. So it's an unequal sharing of electrons. This dash represents two electrons that are being shared by both atoms. So chlorine is the more electronegative of these two. So it's going to have a greater share of the electrons. So this is going to be your partial negative. So you can show that with that delta negative, and then hydrogen is delta positive. The other way you show this is with that arrow. So the arrow points towards the more electronegative atom. Okay, so either way to show that polar bond is just fine. Okay, and then so we talked about electronegativity differences. So you look at the electronegativity value of each atom, and then you subtract and you find the difference. And then the difference is going to determine what type of bond you have. So this table here, you want to record this whole thing, and then you want to know this for the test. So if we have a difference of 0, so if they have the same electronegativity, both atoms in the bond, then it's going to be a difference of 0. Or if it's just a small difference, if it goes up to 0.39, then we consider that non-polar covalent. So it's an equal sharing of the electrons. Once you get to where there's a difference of 0.4 to 0.99, then we call that moderately polar. So it's not an equal sharing. One atom has a greater share. Once you get greater than 1, so 1 to 1.99, then it's one of the atoms has a much stronger pull than the other one. So we call that very polar. Okay, so it's not an equal sharing at all. One side has a much greater share of the electrons. Once you get to 2, then we call that it's ionic, where you have a complete transfer of electrons. So we start equal sharing, unequal sharing, very unequal sharing, and then a complete transfer. All right, so you want to know this whole table for the upcoming test. Okay, so the next thing we have now, this is intermolecular forces, or attractions between molecules. So these are bonds that are between molecules, all right? So we've talked about a lot about covalent and ionic bonds. Those are bonds within a molecule that hold it together. These are different. So these are going to be bonds between different molecules. They're called intermolecular forces or intermolecular attractions. And they're quite a bit weaker than either ionic or covalent bonds, okay? They're a lot weaker, but they do determine some properties for these molecular compounds. One thing we look at is the state of matter. So they determine properties of molecular compounds. They determine if a molecular compound is a solid, liquid, or a gas. So if these molecular compounds have stronger intermolecular attractions, then they tend to be a solid. If they have really, really weak intermolecular attractions, then it's easier for them to separate, the molecules to separate and turn into a gas. And in between you have liquids. Now there's 3 types of these, so that you'll want to know about all those. Okay, so the first one is dipole interactions. So in terms of strength, this one is in the middle. So this is when you have polar molecules and they're attracted to one another. So you have 2 different polar molecules, and the negative end of one polar molecule will be attracted to the positive end of the other polar molecule. So they act like little magnets. So the slightly negative end is attracted to the slightly positive end. So you want to get this, and you probably want to draw, you don't have to draw both of these pictures, but one of them will be good. Next you have dispersion forces. So dispersion forces happen between nonpolar molecules, and it's caused by the motion of electrons. And when you have nonpolar molecules, you have an equal distribution of the electrons, but the electrons will move around, and every once in a while you get more electrons on one side of the molecule, and that creates what's called a temporary dipole. So it looks like this. This is an even distribution of the electrons, but every once in a while the electrons will shift to one side, and this is an unsymmetrical distribution. So this is what a temporary dipole looks like. So it's only a temporary dipole, so it ends up being a very weak force. So this is the weakest of the 3 intermolecular forces. Okay, and then the combination of these first 2 are called, collectively they're called van der Waals forces. So the dispersion forces and the dipole forces are both considered van der Waals forces. The last one is called hydrogen bonds. So this is the strongest of the intermolecular attractions, and this occurs when hydrogen is bonded to either fluorine, oxygen, or nitrogen. So this happens because between hydrogen and these other 3 atoms, there's a large electronegativity difference. And these atoms are small. Well, I mean, all atoms are small, but these are smaller than average. So the different molecules can get very close to each other, and that creates a stronger intermolecular attraction. So the best example of this is water, and you want to draw this picture down here. This is a water molecule right over here, and this is another water molecule right over there. And within that water molecule, it's a covalent bond that holds it together. Now the hydrogen bond is between 2 different water molecules. So it's between the hydrogen of one water molecule and the oxygen of a different one. Because the oxygen is the negative end of this molecule, the hydrogen is the positive end of that water molecule. So they're attracted to each other because they have opposite charges. So they're attracted to each other, and that's called a hydrogen bond. Okay? All right, so water is the best example of that. So make sure you have this diagram right there. And that's all for the section 4 notes. Have a great day.